All right, philosopher, welcome to another deep dive.
Yeah.
As always, we're excited to explore a new topic, and today we're looking at something that I know is close to your heart.
Absolutely.
And that's the idea of scientific objectivity.
It's a big one.
It is a big one.
Huge.
So this idea that scientific claims, methods, results, and even the scientists themselves should be free of particular perspectives, values, biases, or interests.
It's really interesting to think about because on the one hand, like you said, it's something that as a philosopher, I care deeply about.
Right.
Getting to the truth of the matter.
Right.
But on the other hand, how is that even possible?
Yeah.
We're all coming from somewhere.
Right.
With our baggage and our experiences.
Exactly. And that's really the heart of what makes this concept of scientific objectivity so fascinating, but also so tricky to pin down.
Yeah.
And it really gets to the core of why we even value science in the first place, you know?
Absolutely.
It's seen as this authoritative source of knowledge because it's supposed to be objective. Right. So for this deep dive, we're turning to the Stanford Encyclopedia of Philosophy.
Love it.
They have an excellent entry on scientific objectivity. And we're going to try and unpack some of the key ideas and debates surrounding this concept.
Should be fun.
It should be fun. So let's just jump right in, okay?
Okay.
So one of the most common ways to think about scientific objectivity, and I think this is kind of like the starting point for a lot of people, is this idea that it's about being faithful to the facts.
Yeah, like science at its core, it's all about discovering the truth.
Right.
Uncovering facts and then using those facts to explain the world around us.
Right.
I mean, you see this idea going way back, right, with Aristotle, and then you have the huge empiricist tradition,
right,
like Locke and Hume. They were all about basing knowledge on experience, on observation, on those hard, cold facts.
Right, and that it seems very intuitive, right? It's like, well, if you can strip away all the subjective stuff, the opinions, and just get down to the raw facts, then you're being objective.
Right.
Right, and there were a lot of 20th century philosophers that were really grappling with this idea.
Oh yeah, tons of them, like the logical positivists.
Yeah.
Like Carnap and Hempel.
Yeah.
They were all about trying to find a way to ground scientific knowledge in these really firm foundations.
Right.
To come up with like a surefire method for discovering the truth.
Right, right. And Popper too, right, with his emphasis on falsifiability as a way to distinguish science from non-science.
Absolutely. He was saying, look, a real scientific theory, it should make predictions.
Right.
That could be tested. And if those predictions turn out to be wrong,
right,
then you got to be willing to throw the theory out.
You got to abandon it.
Exactly. That's how science progresses.
Right, right. And then there's Reichenbach, who was all about distinguishing between the context of discovery and the context of justification.
Yeah, he was saying, look, it doesn't really matter where the idea for a theory comes from. Like what matters is how it's tested and justified by the evidence.
Right. And it almost feels like this is kind of leading towards this notion of a view from nowhere, right? It's like if you could just step outside of yourself, step outside of your own perspective and just see the world.
Like a God's eye view.
Yeah, exactly. Purely objectively, the facts as they are untouched by human interpretation.
Yeah, but that's where things start to get a little sticky, don't you think?
Yeah, because it's like how do you actually achieve that view from nowhere?
Right.
We're always seeing the world through our own senses and our own experiences and our own cultural lens.
Yeah, and even if we could somehow remove all of our own individual biases, there's still the fact that we're human.
Right.
We perceive the world in a particular way.
Right.
Our brains are wired a certain way.
Right.
We use language to make sense of things.
Right.
And that language is loaded with assumptions and interpretations.
Right, right. So it's like even if we could somehow get rid of all of our individual subjectivity, we're still stuck with this human subjectivity.
Exactly. We can't escape it.
We're trapped.
In a way.
Yeah. And there's this great example in the Stanford Encyclopedia entry about a tree.
Oh, yeah. I love that one.
Yeah. It's like, imagine you're looking at a tree, and as you walk towards it, your perspective changes.
Yeah.
Right? The tree looks different from different angles, but we know that the tree itself isn't changing.
It's still the same tree.
It's still the same tree. It's just our perception of it that's changing.
Right.
Right? So how do we reconcile that with this idea of scientific objectivity?
Right.
Is it even possible to get to that objective perspective, independent understanding of the tree?
Yeah, that's the $1 million question, isn't it?
It is.
And it's one that philosophers have been wrestling with for centuries.
Yeah.
I mean, you have someone like Paul Feyerabend,
Yeah.
who argued that this whole idea of a view from nowhere is a complete illusion.
Yeah.
He was like, look, there's no such thing as a purely objective, perspective-free observation.
Yeah.
Every observation is always made from a particular standpoint with a particular set of background assumptions and theories.
Right.
And he even goes so far as to say that our epistemic activities can actually, like, reshape the cosmos itself.
Whoa.
I know, right?
That's a big claim.
It's a huge claim.
Yeah.
But he's saying that, like, the way we think about the world, the way we investigate it, the kind of questions we ask, those things can actually, like, influence the way the universe appears to us.
So he's saying it's not just that we're interpreting the world differently, but that we're actually shaping the world through our observations and our theories.
Exactly.
That's fascinating.
It's mind-blowing.
Yeah.
I mean, think about it. Like, our understanding of the cosmos has changed so much over time.
Right.
We went from explaining things in terms of gods and spirits to explaining things in terms of atoms and quarks.
Yeah.
And Feyerabend would say that those different explanations are not just like different interpretations of the same underlying reality. They're actually like different ways of constructing reality.
Wow.
I know, it's trippy, right?
Yeah. That's really thought-provoking.
It's like a game changer.
Yeah, so if Feyerabend is right, then this idea that we can just strip away all the subjective stuff and get down to the raw facts, that seems pretty shaky.
Yeah, it's pretty much impossible, according to him.
Right.
Because the facts themselves are always already loaded with theory and interpretation.
Right. So it's like this whole picture of science as this purely objective pursuit of truth starts to look a lot more complicated.
Much more messy.
Yeah, much more messy and maybe even a little bit more human.
Right, because we're the ones doing the science.
Right.
With all our flaws and limitations.
Exactly, and our values and our interests.
Absolutely.
Right. And that leads us to another really important aspect of this discussion of scientific objectivity.
Okay.
Which is the role of values.
Right.
So the question here is, to what extent are scientific claims, methods, and results influenced by value?
It's a huge question.
Yeah.
And there's a lot of debate about it.
Yeah, and there are different types of values that we need to consider, right?
Yeah.
So there are these cognitive values or epistemic values.
Yeah, like accuracy, simplicity, scope, coherence.
Right.
These are things that scientists typically value in their theories.
Right. They're kind of like the internal goods of science.
Exactly. They're the standards by which scientists judge the quality of their work.
Right.
And you could argue that these cognitive values are actually indicative of truth.
Mm-hmm.
Like a theory that's accurate, simple, and coherent is more likely to be true than a theory that's not.
Right.
So in a way, these values are helping us get closer to the truth.
Right. And then you have Kuhn's view that these values actually define the shared commitments of a scientific community.
Yeah, he was saying that like scientists within a particular field, they share these values and they use them to evaluate theories and to guide their research.
Yeah.
So it's not just about individual scientists having their own personal values.
Right.
It's about the community as a whole having a shared set of values.
Right. And these values are important because they help to ensure that science is rigorous and reliable and that it's moving in the right direction.
Yeah. But even with these shared values, like, there can still be disagreements about how to rank them or how to apply them in specific cases.
Right. Because, like, one scientist might prioritize simplicity over accuracy, while another scientist might do the opposite.
Right.
Right. So there's still this element of subjectivity even within these cognitive values.
Exactly.
Right. And then on top of that, you have these contextual values.
Yeah, the stuff that comes from outside of science,
Right.
like social, political, economic, religious values.
Right. And those can really start to muddy the waters.
Yeah, because they can influence the questions that scientists ask, the methods they use, the way they interpret their results, and even the way they communicate their findings.
Right. And this can lead to something called preference bias.
Yeah, where the research is skewed towards the interests of the sponsors or the funders.
Right. Or the researchers themselves.
Yeah, or their own personal beliefs.
Right. And that's when things get really tricky.
Yeah, because it can undermine the integrity of the science.
Right. Because it's no longer about pursuing the truth. It's about getting the results that you want.
Exactly.
Right. And so this leads us to the value-free ideal.
The VFI.
The VFI, which is this normative claim that scientists should strive to minimize the influence of contextual values on their scientific reasoning.
Especially when it comes to gathering evidence and accepting theories.
Right, because those are the core activities of science.
Yeah, if those are corrupted by values, then the whole enterprise is in trouble.
Exactly.
But is it even possible?
Right, that's the question. Is it even possible to achieve this value-free ideal?
Right.
And that's where the value neutrality thesis comes in. The VNT, which is the descriptive claim that scientists can, in principle, gather evidence and assess theories without making contextual value judgments.
So the VFI is saying that they should.
Right.
And the VNT is saying that they can't. Like,
Right.
it's possible.
Right. So the VNT is really about the possibility of value-free science.
Yeah.
While the VFI is about the desirability.
Exactly.
Right. Okay. So we've got these two big ideas on the table.
Yeah.
The VFI and the VNT.
And they're both super controversial.
They are super controversial.
Lots of debate about whether either one of them is actually achievable.
Right. And Hugh Lacey, he kind of breaks down this idea of value-free science into three components.
Yeah. Impartiality, neutrality, and autonomy.
Right. Can you unpack those a little bit?
Yeah. So impartiality basically means that you're judging theories based solely on their cognitive merits.
Mm-hmm.
Like how well they fit the evidence, how simple they are, how much they explain.
Right.
You're not letting your own personal values or biases creep in. You're being impartial like a judge in a courtroom.
Right. Right. And neutrality means that the theories themselves are value-free.
Yeah, they're not making any claims about what's good or bad, right or wrong.
Right.
They're just describing the world as it is.
Right, right. So a neutral theory wouldn't say, like, this is a good way to organize society or this is a bad economic policy.
Exactly.
They would just say, this is how societies are organized or this is how economic policies work.
Exactly.
Right. And then autonomy is about the research agenda itself being value-free.
Yeah, like the questions that scientists choose to investigate. The methods they use, the way they design their experiments, all of that should be driven by the goal of increasing knowledge.
Right.
Not by any external values or agendas.
Right, right. So it's like a three-pronged approach to achieving value-free science.
Exactly.
You got to have impartiality in the evaluation of theories, neutrality in the theories themselves, and autonomy in the research agenda.
That's the ideal.
Well,
anyway.
Right, but it's a tough one to achieve, isn't it?
It is.
Yeah, and one of the reasons it's so tough is because it's hard to draw a clear line between cognitive values and contextual values.
Yeah, they can get all mixed up together.
Right.
Especially in fields like the social sciences.
Right.
Where the very concepts you're using are often loaded with values.
Right. And John Dupre, he talks about these thick ethical terms.
Yeah, terms that have both descriptive and evaluative content.
Right. So it's like you can't even describe a phenomenon neutrally because the language itself is already infused with values.
Exactly, like if you're talking about something like poverty or crime or justice. Those terms are all loaded with moral and political baggage.
Right.
You can't just strip that away.
Right. And Richard Rudner, he makes this really interesting argument about the role of values in theory acceptance.
Yeah, he says that scientists are always making value judgments when they decide whether to accept or reject a hypothesis.
Right.
Because they have to consider the consequences of being wrong.
Right, and he uses this great example of drug testing.
Yeah.
Right, so imagine you're testing a new drug.
Okay.
And you have to decide whether it's safe to release to the public.
Right.
So you do your tests and you gather your data,
Mm-hmm.
and then you have to make a decision based on that data.
Right.
Do you accept the hypothesis that the drug is safe,
Mm-hmm.
or do you reject it?
Mm-hmm.
Right? And Rudner's point is that that decision is not purely objective.
Right.
Because it depends on how you weigh the different types of errors.
Right?
Right.
There are two ways you can be wrong.
Right.
You can accept the hypothesis when it's actually false.
Mm-hmm.
That's a false positive.
Right.
Or you can reject the hypothesis when it's actually true.
Mm-hmm.
That's a false negative.
Right. And those two types of errors have very different consequences.
Huge consequences in the case of a drug.
Right.
I mean, if you accept the hypothesis that the drug is safe and it's not,
Yeah.
people could die. But if you reject the hypothesis and the drug is actually safe,
Yeah.
then people might miss out on a life-saving treatment.
Right.
So how you weigh those consequences, that's a value judgment.
It is.
It's not something you can just read off the data.
Right. And Hennepel, he actually tried to address this issue by distinguishing between confirmation and acceptance.
Yeah, he said that confirmation is a logical relationship between evidence and hypothesis.
Mm.
Like if the evidence supports the hypothesis, then the hypothesis is confirmed to some degree.
Right.
But acceptance is a decision.
Right.
It's a choice that scientists make.
Right.
And that choice is influenced by values.
Right. So Hempel is basically saying that we can be objective about how much the evidence confirms a hypothesis.
Yeah.
But we can't be objective about whether to accept that hypothesis because that involves weighing the risks and benefits.
Exactly.
Which is a value judgment.
Absolutely.
Right. And Helen Longino and Heather Douglas, they take this argument even further.
Oh, yeah. They're like, look, it's not just theory acceptance that's value-laden.
Mm-hmm.
It's the whole scientific process.
Right. From start to finish.
From the questions you ask, to the methods you use, to the way you interpret your results.
Right.
Values can creep in at every stage.
Right. And Douglas, she has this really fascinating case study of the dioxin experiments.
Yeah.
Where she shows how concerns about public safety influenced the way the experiments were designed.
Right. And how the data was interpreted.
Right. So it's like these values about protecting public health were actually shaping the science itself.
Exactly.
Right. And Philip Kitcher, he brings in this idea of significant truths.
Yeah, he's saying that science isn't just about discovering any old truth.
Right.
It's about discovering truths that are significant.
Right. Truths that matter.
Exactly.
And who decides what's significant.
Well, that's where values come in again.
Right. Because our values determine what we think is important.
Exactly.
And what we think is worth investigating. Right.
Yeah.
So again, it's like values are playing this really crucial role in shaping the direction of science.
They're unavoidable.
They seem to be.
At least according to these folks.
Yeah. Okay. So we've talked about objectivity as faithfulness to facts, and we've talked about the role of values.
Yeah.
Now let's move on to another really important way of thinking about scientific objectivity.
Okay.
And that's as freedom from personal biases.
Right. So this is the idea that science should be as free as possible from the idiosyncrasies of individual researchers.
Right.
Like their personal beliefs, their prejudices,
Yeah.
their quirks, their blind spots.
Right. Because if science is just a bunch of subjective opinions,
Yeah.
then it's no better than any other form of knowledge.
Right.
Right. So the goal here is to find ways to minimize or eliminate those personal biases.
Yeah.
And one of the most common ways to do that is through measurement and quantification.
Right. Because numbers are supposed to be objective.
Yeah.
They're not influenced by personal feelings or beliefs.
Right.
Yeah.
So if we can quantify our observations
Yeah.
and express them in numerical form,
Mm.
then we're less likely to be swayed by our own biases.
Right.
And the Stanford Encyclopedia entry actually has this really interesting example of temperature measurement.
Oh, yeah.
Yeah. Can you talk about that a little bit?
Yeah. So early attempts at measuring temperature were all over the place.
Yeah.
Like people were using different materials, different scales.
Right.
And there was no real agreement on what temperature actually was.
Right.
But eventually scientists settled on using air thermometers.
Right.
And this was based on a principle of minimalist overdetermination,
Right.
which basically means that they were trying to find a way to measure temperature that relied on as few assumptions as possible.
Right.
Because the more assumptions you make, the more room there is for bias to creep in.
Right. Right. So they were trying to find like the most objective way to measure temperature.
Exactly.
Right. And what's interesting is that even something as seemingly simple as measuring temperature involves a lot of background assumptions and theoretical expectations.
Right. Like you have to assume that the material you're using to measure temperature,
Mm-hmm.
like mercury or alcohol,
Mm-hmm.
expands and contracts in a linear fashion.
Right.
Which is not necessarily true for all materials at all temperatures.
Right.
And you have to assume that the scale you're using,
Right.
like Celsius or Fahrenheit,
Mm-hmm.
is actually measuring what it claims to be measuring.
Right.
Which, again, is not something you can just take for granted.
Right. Right. So even something as basic as measuring temperature is not as objective as we might think.
It's loaded with assumptions and interpretations.
Right. And we see this even more in the social sciences,
Oh, yeah.
where the concepts we're trying to measure are often much more complex and value-laden.
Right.
And Rice, he makes this really interesting argument about economic indicators.
Yeah, like the CPI and GDP.
Right.
He says that these indicators are not just objective measures of economic activity. They're also shaped by normative assumptions about what constitutes economic well-being or progress.
Right. So it's like we're building our values into the very way we measure the economy.
Exactly.
Right. And that's really fascinating.
It is.
Yeah. So even when we're trying to be objective and quantitative,
Yeah.
our values can still sneak in.
They're sneaky little buggers.
They are sneaky.
Yeah.
So what do we do about that?
Well, one thing that scientists have tried to do is to develop more standardized and automated methods of measurement and data analysis.
Right.
The idea is that if we can remove the human element as much as possible, then we can reduce the potential for bias.
Right, and this is where the concept of mechanical objectivity comes in.
Yeah, Daston and Gallison, they came up with this term to describe this ideal of using machines to eliminate human subjectivity.
Right.
Like in the 19th century, you saw this huge push towards mechanical objectivity with the development of things like photography and automated recording instruments. The idea was that the machine could capture reality more faithfully than the human eye or hand.
Right, because the machine is not influenced by emotions or beliefs or preconceptions.
Exactly.
Right. And Theodore Porter, he has this really interesting perspective on this whole trend towards quantification.
Right. Yeah, in his book, Trust in Numbers.
Right.
He argues that quantification is often a response to a lack of trust.
Right.
Like when people don't trust each other's judgment, they turn to numbers as a way to make decisions.
Right.
Because numbers are seen as more objective and impartial.
Right. And he gives the example of scientists advising on public policy.
Yeah.
Where their personal or financial interests might be called into question.
Right.
So they use numbers to kind of shield themselves from accusations of bias.
They're like, look,
yeah,
I'm not just giving you my opinion.
Right.
I'm giving you the numbers.
The numbers.
Or numbers don't lie.
Right. And that's a really interesting point because it suggests that objectivity is not just about being true to the facts. It's also about being seen as objective.
Right. It's about credibility and accountability.
Right. And that's really important in a lot of contexts, like policymaking or legal proceedings.
Absolutely.
Where trust is paramount.
Yeah.
Right. Okay, so we've talked about mechanical objectivity and the role of quantification.
Yeah.
Now let's talk about another tool that scientists use to try to achieve objectivity.
Okay.
And that's statistics.
Yes, the language of science.
It is the language of science, and statistics are often seen as the gold standard for objective reasoning.
Right, because they allow us to analyze data in a rigorous and systematic way.
Right, and to draw inferences about populations based on samples.
Exactly.
Right, and the Stanford Encyclopedia entry focuses on the frequentist approach to hypothesis testing.
Yeah, which is one of those common approaches in science.
Right. Can you give us a quick rundown of how that works?
Yeah, so basically you start with a null hypothesis, which is the hypothesis that there's no effect or no difference between groups.
Right.
And then you collect data and you see how likely it is that you would have gotten that data if the null hypothesis were true.
Right.
And that likelihood is expressed as a p-value.
Right.
And if the p-value is low enough,
right,
typically below 0.05, then you reject the null hypothesis.
Right. And that's seen as evidence for the alternative hypothesis.
Exactly.
Right. So it's like a way of using probability to make decisions about whether to accept or reject a hypothesis.
Right. And it's supposed to be objective because it's based on math.
Right. It's not just based on someone's gut feeling or intuition.
Exactly.
Right. But there are some problems with this approach.
Oh yeah, plenty of problems.
Right. And one of the biggest problems is that it's susceptible to questionable research practices.
Oh, yeah, the QRPs.
The QRP.
Like p-hacking, arcing, data dredging.
Right, all those ways that researchers can manipulate their data or their analyses.
Yeah, to make their results look more significant than they really are.
Right, and this can lead to a lot of false positives in the literature.
Yeah, and that's a huge problem because it means that we're basing our knowledge on findings that might not actually be true.
Right. And John Ioannidis, he has this really famous paper.
Oh, yeah, the one where he says that most published research findings are false.
Rats.
It's a classic.
It is a classic. And it's really sobering because it suggests that even when we're using these supposedly objective statistical methods, we can still be misled by bias.
Right.
And by these questionable research practices.
It's a reminder that science is a human endeavor.
Right.
And humans are fallible.
Exactly. Okay, so we've talked about objectivity as faithfulness to facts, the role of values, freedom from personal biases, and the use of statistics.
Yeah.
Now we need to talk about someone who is deeply skeptical of all of these attempts to achieve objectivity.
Paul Feyerabend.
Paul Feyerabend.
The ultimate scientific rebel.
He was a rebel.
A true maverick.
Yeah, he's like the anarchist philosopher of science.
Exactly. He was like down with the establishment.
Yeah, and he had this this really scathing critique of the whole idea of scientific method.
Yeah, he's like, method schmethod.
Yeah, she's like, who needs rules?
Right. He thought that strict adherence to method actually stifles creativity and progress in science.
Right.
He was all about letting 1,000 flowers bloom.
Right.
Trying out different approaches, being open to new ideas.
Right. And he even had this famous saying,
anything goes.
Anything goes.
Which is probably the most misinterpreted quote in the history of philosophy of science.
It is, because people think he's saying that there's no difference between science and pseudoscience.
Right.
Or that anything is as good as anything else.
But that's not what he meant at all.
Right.
He was just saying that we should be open to different ways of knowing.
Right.
And that we shouldn't be too quick to dismiss ideas just because they don't fit our current paradigm.
Right.
He thought that science had become too rigid, too dogmatic, and that it needed to loosen up a bit.
Right. And he had this really fascinating example of Galileo.
Oh, yeah.
Right. So Galileo was obviously a huge figure in the scientific revolution.
Absolutely.
Right. But Feyerabend argues that Galileo didn't actually follow the scientific method.
Right. He was actually breaking the rules.
Right.
He was using propaganda and rhetoric to persuade people of his views.
Right. And Feyerabend's point is that that's okay.
Yeah, he was like, sometimes you got to break the rules to make progress.
Right.
Especially when you're challenging the status quo.
Right. And Feyerabend was really concerned with the social and political implications of science.
Yeah, he thought that science had become too powerful, too influential.
Right.
And that it was being used to justify all sorts of bad things, like colonialism and imperialism and oppression.
Right. And so he wanted to democratize science.
Yeah, to make it more accountable to the people.
Right. And to give more weight to different ways of knowing.
Exactly. He was a big fan of what he called epistemological anarchism.
Right, which is this idea that there's no one right way to do science.
Right.
And that we should be open to a plurality of perspectives.
That's exactly.
Right. So Feyerabend is really challenging this whole idea that science is this privileged form of knowledge.
Yeah, he's saying that it's just one way of knowing among many.
Right, and that it has its own biases and limitations.
Absolutely.
Right. Okay, so we've talked about Feyerabend's radical critique.
Yeah.
Now let's move on to another perspective on scientific objectivity.
Okay.
And that's the idea that objectivity is a feature of scientific communities rather than of individual scientists or theories.
Right. So this is shifting the focus from the individual to the collective.
Right. Expert speaker.